the feeling you get about him and many, many other scientists is that they really don't want to talk to philosophers.
They don't.
And that's because they learned early on that there are certain questions that you just don't want to address. Like, if you ask Leonard Susskind, look, the fundamental equations of physics, dynamics of physics, they're temporally symmetric, aren't they, Leonard? And he'd say, yeah. But look, we look around the world. We never see people coming out of their graves and growing younger. We never see ice cubes forming out of warm water. Our world is all full of temporal asymmetries. Just what grounds that? Where does that come from? But physicists don't really like to get into this very much or really delve into it in a way that really gets at the bottom of it.
I've done a few introductory kind of pedagogically oriented philosophy episodes with some of our friends like David Albert and Tim, and I was really looking forward to doing one on the philosophy of science with you. But first, something I always find funny is that when I tell non-philosophers that I'm interested in philosophy of math or philosophy of physics, they always give me this incredulous stare because they know what math and physics are, but they had no idea there was such a thing as philosophy of math or philosophy of physics. And I have the sense it's the same for philosophy of science. So I want to start just by asking you what science is, what philosophy of science is, and how they're different, how they overlap.
It's a really interesting question because, of course, there are many, many activities that people engage in: art, music, mathematics, physics, and philosophers come along and they make philosophies of these things. And you wonder, what are they doing, making philosophies of these things? So philosophers sort of ask foundational questions. In the case of science, the question is, well, what is science anyway? I mean, scientists don't investigate the question, what is science? They do things like find out, what mitochondria are, something like that, or what are the amino acids there are. But they don't investigate what is the nature of science. Investigating the nature of science, well, that's something that can be done by different fields. Sociologists can be interested in it because it's a sociological thing. Historians can be interested in it because it's the history of science. But philosophers can be interested in it as a kind of the idea of, philosophers are particularly interested in normative kind of questions. What are scientists aiming to do? What are scientists after? So philosophy of science is characterizing what science is in general, and then a lot of subsidiary questions develop within science. So within science, ideas have developed over the history of science. For example, the one that I'm most interested in is the idea of a law of nature. Now, the idea that there are laws really wasn't part of the way people thought about things until sometime in the 17th century. I don't mean there wasn't anything like it before, but there was. The Greeks and the Romans and Chinese and Indians had some idea like that. But the idea that there are mathematical principles to describe how things move, how planets, pendula, projectiles, and so on move, that only really took root in the 17th century. The central figures, of course, are Galileo, Descartes, Newton. And so the question is, what is a law of nature? That's a philosophical question. Scientists will go and tell you what laws of nature there are, but they won't tell you what laws of nature are. In fact, can I go on a little bit more?
Yeah, please.
Okay, all right. I mean, the way I got into philosophy, when I was an undergraduate at Amherst College, longer ago than I care to reveal right now, I was taking a course in physics, and a course in statistics, and a course in biology, and the notion of probability, concept of probability came up in all those courses. And they didn't seem to be talking about exactly the same thing in each of these courses. And I kept asking, what is that? What is probability? What are you talking about? What are you talking about? And so finally, I think it was the guy in the physics department said, go to the philosophy department. So I went to the philosophy department, and that's how I ended up majoring in philosophy. And so I've spent most of my career trying to come up with an answer to that question and related questions. What exactly is the nature of objective probability and subjective probability and so on? Maybe we want to talk about that later, I don't know.
It's funny, as soon as I asked you the question, what is science, what is philosophy of science, I realized that asking what is science is itself, or it can be itself, a philosophical question. And I'm wondering then if you think it might be fair at all to think of philosophy of science as meta-science in some way, like an abstraction from science, and what philosophy of science might have in common, or how it might be dissimilar from
metaphysics. The methods of philosophers of science can overlap with the methods of science. So I in fact think that the way philosophy of science should be pursued is sort of seamlessly with science, and that I'm in a tradition that follows, I guess, the great American philosopher of science, in my view, is Willard Quine. So philosophers of science are interested in giving explanations at the most foundational and general level, using something like methods of theoretical science, inference to the best explanation, things like that. But philosophy of science is not an empirical, you don't do experiments in philosophy of science. There are philosophers who are interested in doing so-called experimental philosophy, but that's a whole other can of worms, so to speak, or can of something which you don't want to open. So it's not the same as it's doing science. I know, because I also was going to at one point be a biochemist in my life, so I practiced some science. I even published a couple of things in biochemistry. There's an unknown fact, don't you?
Yeah. Okay. I thought I had your timeline all figured out.
So I have some idea. I mean, I wouldn't really say I am a scientist or could do science now, but I have an idea about what goes on, really. And of course, I've studied physics, so I know what goes on in physics, but not as an experimentalist. If you were to put me into a laboratory, you would want to get me out of there as soon as you can.
Yeah, you kind of have a mad scientist look, especially with the sunglasses.
I'm not angry at anybody, actually.
And maybe a happy mad scientist. Well, I think it would be nice to start with some of the classical questions in the philosophy of science. One of the major ones that comes to mind is, I guess I've already asked this, what is science? But more particularly, how do you contrast science with pseudoscience, and how has this been done historically?
Yeah, so that's really interesting. I'm not sure that I have anything so incisive to say about it. I've been interested in it. I've even taught a course on science and pseudoscience. So, of course, science has a lot of prestige, allegedly. At least they get the grants. So there are people who want to do science but don't know the first thing about doing science. But they invent something that they want to get the money for, or at least want to get the prestige for. And it's really pseudo, and it's not the real thing. Let's think, what's a really good example of a pseudo?
Of pseudoscience?
Pseudoscience.
Well, the obvious examples, I mean, I was thinking of Popper when I asked this question. I had in mind astrology, perhaps, or, I mean, for Popper, I understand psychoanalysis or Marxism might have also counted as pseudoscience, but maybe we ought to stick with astrology.
Astrology is a straightforward example. I mean, I have known astrologers. A very good friend of mine, can I put in a little side? You can edit, right?
Yeah, I can edit, but
okay.
I just want you to know.
You know George Ray? Have you done George Ray?
Pretty much every time you're going to tell me to cut something out, I know it's going to be funny, so
No, this is not going to be funny. You know George Ray?
No.
He's somebody you should do. His stepfather was an astrologer, a pretty well-known astrologer. So I've heard
Okay,
a lot
well-known
about
astrologer.
that.
I'm not up on the great
George
astrologers.
Ray is a philosopher, a very prominent philosopher of psychology and philosopher of mind. He teaches in Maryland. He's a little bit sick right now, so I don't know if you'd get him to do anything. But so let's see. So astrologers claim that by examining where the positions of the planets and the stars were at various times when you were born or when you had your bar mitzvah or something like that, that they can tell you things about your personality, your nature, who you ought to marry, and things like that. Now, these claims are wild. There's no real understanding, real theoretical backing for why this should be the case. Why should when you were born have anything to do with what your personality is about, where the planets are doing. The planets don't affect your personality in that way. Furthermore, if you subject claims by astrologers, if they make really clear claims, often they don't make clear claims. The claims are vague so that they can they can say they really didn't get it wrong because they didn't really mean that or something like that. But to the extent they can be pinned down, they just don't pass the test. So one of the things about science is that scientists try to put forward, or they should try to put forward, clear hypotheses. I mean, this is a good thing about Popper. Popper emphasized this, that scientists should put forward clear hypotheses which have clear predictions and then subject them to severe tests. I think that's the good part about Popper. He just went overboard with that.
Well, maybe we should talk a bit more about Popper, just because he's crucial to most introduction to the philosophy of science courses. Maybe falsification and its role in his philosophy of science might be something worth covering.
Okay, so let's see. I'll try not to be too glib about this. When I first started teaching, I had a colleague who was a Popperian student, and in the department that I was teaching then, I got to be known as the Popper Stopper.
The Popper Stopper, I like that.
Because I think Popper went just too far, and he oversimplifies many, many, many things in my view. On the other hand, I think it was very good. It was a good event that he was there and it happened, and he was clear about things. I think it was a very good thing that he was there. So Popper was famous for putting forward a view called falsificationism, the idea that scientists should put forward theories or claims about the world and then attempt to falsify them. And that you could never confirm a hypothesis, according to Popper, or some parts of Popper, so he modified this at certain points. So you should never say, you have good reason to think that this is closer to the truth than that. Although he did try to develop a conception of closer to the truth, actually, which is one of the interesting projects that you might do in philosophy of science. This was very, very influential idea. I mean, that's very important. It influenced, one place we might want to follow up, it influenced a whole way, or is very much connected to a whole part of the way statistics is done. And statistics is very important in doing science. And I don't know if you want to get into this later, but now there's something going on called the statistics wars. So it's been going on for a while, but the wars have been starting up again, apparently, from some emails I've gotten recently.
Oh, yeah. Well, probability is certainly on my list for a topic that we need to get to, especially in conjunction with something you've already mentioned, which is laws of nature. But you're right that I would like to hold off on that for a little while.
Okay, about Popper and this. So I was very much brought up at the graduate school I went to, one that you know about well, at Stanford. One of my teachers was Patrick Suppi, so I'm sure has a big influence, even though he still does for a while. As a Bayesian, I learned about the approach to understanding scientific inference via something called Bayes' theorem. Now that also can be oversimplified a lot, and maybe we want to talk about that a little bit more later on. But when I first started doing philosophy of science at the department I was at then, it was sort of Bayesians versus Popperians. I'm not sure this is even the way anybody would think about things nowadays, but in fact, I edited an edition of Synthèse, I think called, it's the very first thing I did, I think, in philosophy, Bayesians versus Popperians. And basically, Bayesians thought of scientific inference as scientists start out with certain degrees of belief or amounts of confidence in various hypotheses. They then do experiments, they get evidence, and they update the degrees of belief in accordance with certain rules which seem to follow from principles of rationality, which we can talk about why they make sense. Popperians really didn't like this. And so that was what the fight was over in those days. And in fact, in statistics, the two approaches to statistics, the broad approaches to statistics, I'm oversimplifying, are so-called orthodox or significance testing on the one hand, and Bayesian on the other hand. And really, that's kind of like a following of the dispute between Bayesians and Popperians in philosophy of science.
Before we move on from Popper, there are two specific things I'd like to get your takes on, even though they might not fall under the philosophy of science. One is with regard to falsification. You probably know I've done a number of episodes on string theory with some very famous string theorists like Leonard Susskind or Juan Maldacena. And one of the major criticisms of string theory, which for our listeners who might not be familiar with string theory, in a nutshell, though it's obviously much, much more complicated than this, string theory reimagines the point particles and fields of quantum field theory as tiny, one-dimensional oscillating strings along with some other sort of fundamentalia. But what people allege is that it's unfalsifiable, in part because there are currently no conceivable experiments that could be run to test it. And what I am wondering is whether or not you think, a la Popper, that this should preclude us from viewing string theory as science.
So the two reasons that something might be unfalsifiable. One is that it's the theory itself is so developed so that no conceivable experiment.
Thanks for qualifying my word conceivable. I mean, you used it much better than I did. I should have said no practical experiment can be done.
No conceivable experiment could falsify it. If that is really the case, then it's not science. But if there's no experiment that could be done now that can't falsify it, that doesn't mean that if you work on the theory and you develop things and you develop new technology and so on, you couldn't falsify it. There are all sorts of hypotheses in cosmology that can't be falsified now, but are very interesting and important, and there were ones at times which couldn't be falsified and later were able to be falsified or I'm not sure verified is the right word, but they passed tests, falsification tests. So that's a very important distinction. As far as I understand, I'm no expert in string theory. I understand it to an extent, but I'm no expert in it, far from it. There's a problem within the foundations of physics that's super, super important. And that is that the two basic fundamental theories, really one really, really fundamental theory, and that's quantum field theory. And then there's an account of space-time that's general relativity. And it's basically the theory within cosmology is mostly done and stuff in astronomy where strong gravitational fields are involved. But it's definitely the structure of space-time. But these theories do not fit together very well. And this is a question of how to make them compatible with each other. And there are a number of ideas floating around. Have you done Carlo Rovelli, actually?
I'd love to speak with Carlo, but
Carlo's going to be around starting in October.
Oh, really?
Giving a bunch of lectures at Princeton, right? So he has an approach, not string theory, but different kind of approach, and there are a number of other ideas that are around. And I think at this point, yeah, this is such a tough, difficult, interesting problem. Let people think about it. I mean, it would be ridiculous for someone to say, stop thinking about it because you can't falsify it now. And if there are people who say that, screw them.
Yeah, I'm entirely inclined to agree with you on this point, even if there might be other good criticisms of string theory. I don't think falsification is the way to go. The other thing I wanted to ask you about, just because out of intellectual interest, I've done a number of episodes on the show about Marxism. And since Marxism is one of Karl Popper's pet peeves, this again isn't necessarily related to the philosophy of science, but as a philosopher of science, how do you feel about Marxism?
I'm afraid I have a lot to say about that.
Oh.
The first thing that comes to mind is a philosopher whom I knew personally, and when you talk to David Albert, David knew him much better than me, actually, but is one of the most important figures in the history of contemporary philosophy. But he's published almost nothing. This is Sidney Morgenbesser. I'm sure you've heard about him.
Absolutely.
And when Marx comes up, Morgenbesser's famous remark about Marx comes to mind, which is that up until now, people have studied Marx. The time has come to change him.
I've heard Morgenbesser had a lot of really good lines.
Many. Too bad he's not around for you to interview.
Mm-hmm.
He'd be the best I ever knew about. He used to call me up once in a while. I didn't know that person. When I mentioned before I got into philosophy, when I was at Amherst, the teacher I had, who was a philosopher, a guy you probably never heard of named Joe Epstein, who actually was a friend of Pat Suppi's. Incidentally, one of the things about philosophy is you get to know a lot of great people in philosophy, really interesting people. I'm sure you've noticed this because you've gone out of your way to get to know them. I never had any idea when I was a little student at Amherst College that I'd get into such a fantastic field and get to know so many interesting people. So Epstein was my teacher there, was also a co-student with Sidney Morgenbesser, who was a co-student with Pat Suppi's too. I don't know if you knew that or not, at Columbia. So I didn't know Morgenbesser early on. I got to know him when I moved back to New York, and David knew him a little bit, and I got to know him through David. And Morgenbesser knew that I was a guy he could call up and bend my ear on the phone, so he'd call me up from time to time. And every once in a while, my wife would not say, Barry's not here, because she knew I'd be on the phone for an hour or two. Anyway, so Morgenbesser had a lot of great statements. Ask David about more. We could spend the hour just talking about Morgenbesser's statements.
Let's get back to Marxism, and you don't have to say all you have to say on it, but I'd love your thoughts.
Okay, my wife, who I just mentioned now,
yeah.
she's from Budapest. Her family were communists at one point. Parts of her family were. There were also Holocaust survivors. I mean, it's a long story. You don't go into that. But they also became anti-communists. And so she was brought up, and she was born after 56, but she was, her uncle was one of the leaders of the 56 rebellion. He had to leave Hungary. He lives in Paris. Now he's still alive at 98. So she was brought up on sort of the Soviet-style thing until the early 1980s when communism fell. So she really hates that stuff. And she was brought up, she went to Karl Marx University. And when I visited her, when I first got to know her, and I went and we sort of fell for each other there, she took me to Karl Marx University, and there was a bust of Karl Marx in the middle of there. And of course, knowing me, what do you think I did? I separated it from where it was, and I turned it upside down and put him on his head.
That is a very Barry thing to do. Okay, that tells me all I need to know.
Anyway, I don't know really what Karl Popper has to say about Marx. I know he dumped on it a lot because that was what was in the air when he was writing. I think now, that's in the past. I think Marx had many interesting things that should be studied and thought about more seriously now.
One last, quite general question about science and the philosophy of the same is scientific realism. What is this debate of scientific realism?
So there's a debate within philosophy of realism versus idealism or various other things that are modifications of realism. For a while, Hilary Putnam held something he's called internal realism or sort of weak-kneed realism, I don't know, or something like that. And then there's a debate between scientific realism and, or something that's called constructive empiricism and scientific realism. Full-throated scientific realism say what scientists are aiming at is to finding out what the world is really like. I don't know why you'd want to be a scientist unless that's what you wanted to do. Unless you wanted to be one of the tech guys in Palo Alto and you just wanted to get rich, then you might want to be a scientist. So I think if you're interested in science, you want to know what is the world really like. And the next question is, can you actually find out what the world is really like? Well, I think that if you look at the history of science, it's reasonable to say that scientists have found out what the world is really like or close to really like to a large extent. For example, at one point, it was not really clear that the world was made up out of little things with lots of degrees of freedom. You know, got to be called atoms, now elementary particles or something like that. I now think that it's definitely that's the case. In some sense of made up out of. I mean, maybe that's not at the very bottom of the story, but there definitely are atoms and molecules. I've even seen molecules in a microscope, so not that that's the test, but so I think we've found out more about what the world is really like. We found out that the Earth really moves, that the moon moves around the Earth, that the Earth moves around the sun. So scientists have found out what the world is really like. So scientific realists think that the scientists should aim to do that and can succeed to an extent. Whether it could succeed entirely, that's an open question. So-called constructive empiricists, and the famous name there was a very important, significant figure, Bas van Fraassen.
Who I've spoken with on the show.
Yeah, he's great, significant. He, for a while held, I'm not knowing where he is right now about this, but I haven't seen him in 10 years or so. And he held that all science should aim to do is to find out what you would see if you were to do experiments of various kinds. And I think science should aim for that, but the reason you should aim for that is you should find out what the world is really like. And finding out what you see when you do experiments of various kinds tells you something about what the world is really like.
So, are you a scientific realist? Do you believe that science can tell us what the world is really like?
Yeah.
What is the best argument that you've heard for us not being able to believe that science can, in principle, tell us what the world is really like? Maybe in particular about unobservable entities, like water molecules or strings or something like that. We can never get to the bottom of it.
Well, there's an idea that you should only believe in what you could see. Now, I'm very nearsighted, so this would be very limited to me.
Yeah.
Okay.
I assure you I exist.
Okay. I'm often unsure about myself, but I'm glad to hear that you exist. But I think that's ridiculous. We can also believe in things we hear about. And, just when you understand what it is to be a human being, we know that we couldn't even believe in what we see unless we believed about a lot of other things too. Okay, because we can only see the front sides of things. We believe that things have backsides too. Okay, so I think, and one of the, in the 50s and 60s, there was a whole discussion about whether there can be a sharp distinction between what's observable and what's not observable. I think there isn't a sharp distinction between them, and the notions are not that clear, and they're really notions that should go into psychology. They should be studied by psychologists. Anyhow. So I think the idea that you should only believe what you can see is a really bad argument for not being a scientific realist. The argument for not being a scientific realist, which has a little bit of strength, I think, is that scientists have often made mistakes.
Is this the argument about the pessimistic meta-induction?
Yeah.
Could you explain what that is and what those words are? I think that might be interesting for our listeners.
I wish I had a good line to say about a pessimist and optimist, but I think a little bit something will come to mind. But
Norman Finkelstein yesterday said something interesting about Noam Chomsky, which kind of relates, not really, but he said that that Chomsky was not a glass half empty or half full kind of guy. He was just, the glass is empty. I thought that was funny.
Oh, I see. I've met people who said, "Where's the glass?"
Oh, that's a good one too. The pessimistic meta-induction. What is it? What does meta-induction mean?
Okay. So the idea is you're doing an induction, just an induction.
What's an induction?
Okay, an induction is you got some evidence, you draw some conclusion from the evidence. The conclusion doesn't follow with logic validity from the evidence, but you somehow thinks that the evidence provides reason to believe the conclusion. Now, when induction is good and when it's bad, that is one of the most fundamental and important questions in philosophy and philosophy of science. We can come back to that. That's really Hume's problem and Goodman's paradox. Fascinating and interesting things for discussion. I don't know if we want to get into that or not, but I'm quite interested in both those things. So that's what an induction is. It's pessimistic because, with respect to scientific realism, because you think that the evidence we have is that scientists have come up with lots of proposals for what the world is like, and then later it's shown that they're wrong. So maybe anything we come up with, the conclusion that the induction is supposed to lead to, is anything scientists ever come up with is going to be wrong. But I think that's a completely mistaken inference here. First of all, the things that they've come up with, while they've shown to be wrong, they've shown to be wrong in places, but right for the most part. So, for example, the early quantum theory was wrong, but it had a big part that was right that led to better quantum theory. Newton's, to make the most famous example, Newton's classical mechanics isn't right, but Newton said that he was standing on the shoulders of others so he could see further. Now, I don't know that anybody would have the gall to say they're standing on Newton's shoulders. Those shoulders are too high up to get to.
Yeah.
Okay, but certainly in some sense, the one person who could say that would be Albert Einstein. And he certainly was doing that. Okay. So while Newton was wrong, he was on the right track. So Popper noticed this too. You know Popper earlier, and he wanted to come up with the ideas that, well, theories that people have come up and have been falsified, maybe they were approximately true. And he tried to come up with an account of when a theory, or it doesn't have to be anything as fancy as a theory, just a claim, a view, is not true, but it's close to being true. That's a really interesting idea. Popper used the word verisimilitude for that. There have been attempts to come up with more precise and formal accounts of verisimilitude. Some of them are better than others. I'm not sure I'm really on top of that literature right now, but that's an interesting project because we certainly have an idea of when, we certainly think that if we watch two debaters, we think both of them are saying a lot of false things. I won't name names because we're not on a political discussion now, but in a recent debate, I would say one of them was a lot further from the truth than the other one.
Yeah. I have the sense, maybe we've spoken about it before, that you knew Hilary Putnam, who's another big titan in 20th century philosophy, and another titan who is quite connected to this debate about scientific realism.
Yes.
You know what I'm going to ask you. I'm going to ask you, the pessimistic meta-induction is an important argument for the scientific anti-realist, but another argument, this one that is in favor of the scientific realist, is the no miracles argument. And that is attributed to Hilary Putnam. So I wanted to ask you about that one.
Yeah, okay. And afterwards, if you want, I can tell you a story about Hilary Putnam.
You don't want to do it on the air?
Well, it can be on the air because almost nobody knows the story I'm going to tell you.
Okay, great.
And since I'm gonna retire soon, that I'm left knowing that this story almost no one knows this story.
Okay.
Yeah. Okay. All right.
For our listeners, Hilary Putnam really is one of the huge titans.
He is one of the great philosophers. The great philosophers now are thought to be, I believe, Saul Kripke, David Lewis, and Willard Quine. Maybe there's some other names you want to throw in, Wilfrid Sellers. And Putnam is up there, but I think Putnam should be right up there with those at the very top, in my own view. And Sellers should be too. The problem with Putnam is he changed his mind often about things and said he did. He was very, very straightforward. Some of the things he wrote about certain areas, like in quantum mechanics, he was a little bit screwed up about. David, I don't know if you know this, that David was his source in quantum mechanics. So scientists have come up with theories. They look like they're right. Their experimental results are right. I mean, take some examples. Genetics is an example of that. When it first came up, people didn't know anything about genes. When Mendel was coming up with his account of inheritance, nobody knew what DNA was or anything like that. It took a while for people to develop that. It would be a miracle to think that someone could come up with this theory and for it to work out the way it did if it weren't on the right track.
Mm-hmm.
Okay, that's the no miracles argument, and surely Putnam is right about that. Putnam was a scientific realist, but he was not a full-blown philosophical realist. That's maybe for a metaphysics discussion, not for now. Here's a story about Putnam. So I wasn't a student of Putnam's, and I knew him a little bit before, but I only really got to know him because I spent a summer at a summer seminar that he ran in 1986 or 7 or 8, I don't remember exactly the year, and I got to know him quite well in this summer seminar, and we hung out a lot, and I learned a lot from him. I really think I absorbed my philosophical views as much from him as from anybody, although I didn't realize it at the time. So here's the story. It's a story about how I almost killed Hilary Putnam.
Oh my God.
Like I said, you maybe want to edit it out of this. So in Boston Harbor, I got into the habit, you can rent these boats. I used to go kayaking in my youth, and now I'm sure I couldn't do it a little bit, but you can rent these boats which are kind of like kayaks. I think they're called wheeries. They're much bigger.
This is starting to sound like an attempted murder in Boston Harbor late at night.
Right. I wasn't attempting to murder him, I guarantee you, and nothing intentional.
Is the statute of limitations up on this?
He's dead anyway.
Did you
but
have any
no, I didn't want to kill him. I think he was a great human being, actually. To the extent I knew him, I mean, I wouldn't say I knew him really, really personally, but I knew him from this thing. And so I told him about this, that I was going there, and he said he wanted to go out on a wherry because he hadn't done this, one of these boats. So I took him out on the boat. We went on the boat. You rented them in the harbor. You rented them. We were going out a little ways, and he decided to stand up. But you can't stand up in a wherry, because what happens if you stand up?
Tips?
It tips, it capsizes. So he fell into the Boston Harbor. So I had to fish him out of the Boston Harbor. If I didn't fish him out, he wouldn't have made it.
It's a good thing that you were there and you didn't have ill will for Hilary Putnam.
So that's the story.
The last thing, since we've already talked a bit about string theory, which I find quite fascinating, I know that a lot of philosophers don't think the time is right yet to be doing philosophy of string theory, or they think the time is past because string theory is dead and we shouldn't really be doing philosophy of string theory at all. But there is a relevant question related to scientific realism. So I've spoken with Tim Maudlin plenty of times on the show. He says we're not getting rid of H2O. One way or another, no matter what happens with science, it's almost impossible that water as H2O is going anywhere. But he certainly wouldn't say the same thing about strings. He would say either he's very certain the world is not composed of strings or stringy things, or if anything, it is very far from certain that the world is composed of stringy things. I'm wondering if there is a criterion or some set of criteria that you as a philosopher of science or philosophers of science in general would use to make this distinction of when we want to accept an unobservable entity or class of entities, accepting the caveat that unobservable is maybe a nebulous term, into our ontology of what the world is like.
Mm-hmm. I wouldn't look for a criterion for such a thing. It's just sort of got to be on the ground and see what's going on in the field. I totally agree with Tim about H2O. If there's not a worldwide drought, H2O is here to stay. That's certain.
Okay,
we're going to have H2O. String theory, I just don't think it's not clear enough. And I think the reason that there aren't very many philosophers think about it, is because it's hard to learn about it. I've attempted to read some of the work in string theory. Brian Greene is another guy in New York. I don't know if he does interviews or not, but he's a string theorist guy. I've heard him talk about it. I think to get into the mathematics of it the mathematics is very, very difficult and fancy. That's why philosophers are not doing it, I think. It's just hard.
There are some philosophers who are doing it. Jeremy Butterfield, Sebastian DeHaro, Nick Huggett, your student Craig Callender. There are a lot of
Nick was also a Rutgers student.
Yeah. Another topic in the philosophy of science worth broaching, and mind you, we're going to get to natural laws, to probability, to your cup of tea, is fundamentalia, and what is fundamental entities, fundamental theories. But maybe this is a good place to ask, because fundamentalia also has a metaphysical ring to it, and there are lots of debates within metaphysics about what fundamentality even is, if it is a univocal term at all. What is fundamentalia? But first, how do philosophy of science and metaphysics interact or connect? You're smiling. Is that because it's a good question or
it's a really good question?
Okay.
And it's a really central question. So I think people in metaphysics divide up into those who think that metaphysics is its own subject and science is, something there, but you do metaphysics based on intuitions and a history of metaphysics and maybe theology, something like that. And there are those who think that really all metaphysics is understanding what the world must be like for science to be a successful enterprise. That's my view. Now, I might go a little bit further than that, because I think there are other enterprises that people engage in, like art and music, and you might wonder what the world must be like, or what human beings must be like, really, in those cases, more than the world, or reality must be like, for those to be successful enterprises. But science especially is, what must the world be like for science to be a successful enterprise? So I think metaphysics is very closely connected to science. But there are people who disagree with that, for sure. And in the history of metaphysics, for sure. So there were. I was just talking to a student of mine the other day about McTaggart. Interesting guy. Do you know McTaggart at all? Okay.
Well, I don't know him, but...
No, I didn't know him either. But
Yeah.
I did study with a teacher. I'm not sure she knew him, but we studied McTaggart because he was the bad guy in the course. Again, this is just a story. I'm not going to tell you the story.
Are you sure?
I'm sure I'm not going to tell it to you.
Yeah.
You're interested in what you do. I'll tell you who the teacher was.
Okay.
Because when I was an undergraduate teacher, it was Alice Ambrose. Do you know who she was?
Mm-mm.
Alice Lazarowitz, Alice Ambrose, she was the person who knew Wittgenstein and transcribed the Brown Book.
Mm-mm.
I took a great course. She taught at Smith College then, a course in which we read Russell, Moore, and Wittgenstein. She knew Wittgenstein personally. She knew all three of those well.
That's pretty crazy.
That I studied with her is super crazy. And the 5 people who took that course, all of them became philosophers in one way or another.
Well, they're 2 degrees removed now from the Titans.
That I had anything. I mean, I just recently taught a history of analytic philosophy course, and I began by telling the students that I don't really feel that. I don't feel that I know enough to really feel that. I'm not an expert on that stuff at all. But so anyway, McTaggart thought he could go and demonstrate that time doesn't exist with arguments about the nature of time. Or another philosopher at the time, not in this, somebody studied in this course. I'm all over the place here. We read McTaggart and Bradley, another example. He wanted to prove that nothing existed. Okay, we read them to understand why Russell and Moore were reacting against these guys. I found actually Bradley and McTaggart more interesting than I found Moore, who I thought was a bore. Russell, I think, is one of the greats, and Wittgenstein. Talk to some Wittgenstein person. That's interesting. I don't know where Wittgenstein is now. I know there was just a conference because a student of mine came back from that conference at Harvard, where Wittgenstein is still held in high esteem. About called the future of Wittgenstein. That was the conference he came back from. Anyway, but McTaggart and Bradley were the bad guys. They did metaphysics in this old-fashioned way. They didn't bother to study anything about science in order to do their. Now, some people in the history of historians of science, like Kant, he knew something about science, but he didn't really study science. Or Hume, Hume certainly knew something, but I actually went to a Hume scholar recently to find out what is known about what Hume knew about Newtonian mechanics. And it seems to be not a clear answer to that question from what I could see. I may be wrong about this, and there may be Hume scholars who know better about what to say, but Hume certainly knew about it. It was all over England. Did he really know about Newtonian mechanics? I think Lagrange's stuff was already developed in France by the time Hume was writing. I'm not positive about that. But Newtonian mechanics was developed, so I don't know. So most philosophers did not study science carefully. In fact, even some of the greats of the 20th century, like Quine did not really study physics very much. Or David Lewis, who was a chemist, actually learned chemistry and knew something about quantum mechanics and relativity. He wrote a little bit about relativity, he wrote one paper on quantum mechanics, but they were not his main interests. Now, you mentioned Ted Sider. Ted has recently gotten very interested in the foundations of physics because he knows that if he's going to be a metaphysician, he's got to understand physics to an extent. And I think that's 100% correct.
That's something that our friend Tim says, and he said it on the show, that if you want to understand the metaphysics of our world, you need to look at the physics. Tim
wrote a book called The Metaphysics Within Physics. Now, Tim and I draw very different conclusions from what metaphysics you find within physics, but I think that's a good place to look.
Since you mentioned McTaggart, the philosophy of time, or just questions about time, seem like they might constitute a good case study for helping us distinguish a bit between science and metaphysics. Interestingly, a lot of scientists that I speak with about philosophy, where philosophy comes up, such as Leonard Susskind, anything that they don't like, they call metaphysics. So they lump in questions that we might ask about time with astrology or ghosts or phantasms. So they have for a philosopher, a non-standard use of the word metaphysics. But what sorts of questions about time would constitute scientific questions, and what kind might constitute metaphysical questions?
That's a really good question. Just parenthetically, I've never met Leonard Susskind personally. I gather you have.
Oh, yeah.
I've thought sometime when I was at Stanford, thinking about finding his door and knocking on it if he has a door still at Stanford.
I could lead you right to it.
Okay,
But
because I have
tell him I did it.
gone through his lectures. His lectures are great, but the feeling you get about him, and this you might find interesting for what you're asking about, the feeling you get about him and many, many other scientists is that they really don't want to talk to philosophers.
They don't.
Because philosophers, not all scientists are like that. Sean Carroll, who you probably have talked to, is a big exception. Or I can think of other scientists like that. I mean, Shelley Goldstein's another example. He's a mathematician, but but there are others who are not like that. But and that's because they learned early on that there are certain questions that you just don't want to address. Like if you ask Leonard Susskind, look, the fundamental equations of physics, dynamics of physics, they're temporally symmetric, aren't they, Leonard? And he'd say, yeah. Schrodinger's equation is temporally symmetric, and you might have to specify a little bit more what you mean by that. So that any sequence of macroscopic events that happen in one temporal direction that are compatible to laws, they can happen in the opposite temporal directions compatible to laws. So you'd have to say yes. But look, we look around the world. We never see people coming out of their graves and growing younger. We never see ice cubes, forming out of warm water. Our world is all full of temporal asymmetries. And of course, what grounds that? Where does that come from? Now, there's the idea, and you'll talk to David, I'm sure, about this because he's the world expert on this, that it somehow is connected to statistical mechanics in some way. That's right. But physicists don't really like to get into this very much or really delve into it in a way that really gets at the bottom of it, as I think Leonard Susskind wouldn't. I'm not sure, he probably knows more about this than most, but many wouldn't. Or in quantum mechanics is the famous example. As you're sure you know, as you've talked to Tim and David, and I think even me a little bit about, is the famous measurement problem in quantum mechanics. Well, that's a problem. It was pointed out by a physicist originally, by Schrodinger and Einstein originally. Physicists wanted to sweep it under the rug, and it took philosophers to keep taking it out from under the rug and saying, we got to think about this, and it really is actually central and important to understanding what quantum mechanics is about. So here, there's a smooth connection between physics and philosophy of physics, where the philosophers of physics were doing what the physicists should have been doing, really, in my view.
A few minutes ago, you used the phrase fundamental equations, and that brings us back to fundamentalia. Mm-hmm. What does a philosopher of science have to say about fundamentalia? What sorts of things might a philosopher of science discuss regarding fundamentalia? Theories, equations, and entities.
Let's talk about entities first and a little bit about history.
Please.
From the very beginning, from the Greeks, there was the idea, and it's a very common idea, that you explain complicated things in terms of their parts, simpler things, in some sense of parts. So, it's the idea the earth is made up out of earth, or the world is made up of earth, air, water, and fire, is that the word? Or atoms, or everything is water. Is that what Thales said? Everything is water? I think it was made of a misprint. He said everybody was after my daughter. I never really understood what that was about, but anyhow.
I heard that he fell into a well.
Fell into a well, that's what it was. Everything was water. That's right, that's the story. Anyhow, so that's an idea, and it's a very attractive idea, that the world is made up out of, reality is made up out of fundamental parts. It's an idea in science. Now, my idea, if we get into my ideas about metaphysics, I'm going to put them off for a while. My ideas about metaphysics are a little more subtle and more complicated than that. But the idea in science is certainly there, that we want something at the bottom in terms of which we can explain other things. So we start out with something that's, we might call basic or fundamental, at least for a while. We may find something more fundamental than that. We start out with something that's, we think of as fundamental. Maybe they're atoms, and maybe atoms are made up out of electrons and protons, and when electrons and protons are put together in certain ways, we get atoms of certain signs, and atoms are put together in various ways in accordance with certain laws of physics. We can get molecules of various kinds, which explains why they can be water, why they can be acids, why they can be bases, and so on, like that. And these explanatory frameworks work beautifully, I think. So that's the idea, okay, of why this is fundamental. Now, as far as laws are concerned, of course, when you have fundamental things, you only can explain what they're doing if you have certain principles or regularities that they conform to. These are thought to be the laws about them. We haven't talked about what laws are. We can come to that in a while. But there are certain regularities about them. These would be the fundamental laws about the fundamental things. When you get more complicated things, there'll be non-fundamental laws, or sometimes called special science laws. And there's a question about how the non-fundamental and the fundamental are related to. That's a kind of metaphysical or scientific metaphysical question, also a very important question in the philosophy of science.
I'm glad you bring up the special sciences, because one of the other topics I wanted to talk about, and now maybe is a good time, is the reduction of the special sciences to, well, the reduction of some special sciences, or a special science in particular, biology, to chemistry and then physics, and how this relates to laws and also to fundamentalia, because there are laws in biology, for instance, like scaling laws, that presumably reduce to chemistry and then to physics. And I'm wondering how this works and how you think about reduction and fundamentalia in this context.
So the whole business about reduction often brings people up into fighting modes.
Really, it's that contentious.
The reductionists and the anti-reductionists. I think this is not the right way to look at things exactly. Somehow the anti-reductionists think, gee, if you're going to be reductionist, all the money will go to the physics department. So no, but that won't happen, because the biologists are actually the ones who are finding cures for diseases and better ways to grow corn and stuff like that. So that's not going to happen anyway. Look, either you think that the world is made up out of fundamental physical things, and that's all the fundamental things there are, or you think that in addition to fundamental physical things, there are fundamental biological things. So the question about life, that's one really interesting thing. For a certain time in the history of science, it was thought that there was a certain, a substance or a fluid or I know what, something called elan vital, that got sprinkled onto certain physical things that made them alive. Now, I don't think anybody thinks anything like that now. Of course, there's some people who think that there was just dust, and then it took a deity to wave a wand or whatever deities do to make the thing to be alive. There may be people who think that now, too. I don't really know about that, but I don't think that. Okay. But people do think this about consciousness now, for sure. Dave Chalmers is an example of someone who's argued, strongly that given all the fundamental physical stuffs in the world that's not sufficient to account for why there's consciousness in the world too. So when the world was made, all the fundamental physical things had to be put in place, then also consciousness had to be added to the world. Now, I don't think that. So I'm a reductionist to the extent that I think all there is the fundamental physical stuff. There are some people who think that no, some people who, Nancy Cartwright is a good example of someone who thinks this is just taking stuff way too far. They think there's a lot of different stuff in the world at different levels, and that the whole idea of building up the world out of fundamental physical stuff. Parenthetically, have you spoken to Nancy Cartwright?
No. but we might at some point.
She's a fascinating person. I don't know her very well, but I'm not going to tell the story I know about her.
Okay, you're not? Darn.
Okay. But I think her work is very interesting, for sure. But she'd be on the opposite side of this from me. And, she wrote at times things like, she said, the world is variegated, it's a mess. It occurs to me now that reductionists like me tend to be people who in their offices are a mess. My guess is, though I don't know this, that Nancy Cartwright is a very neat person. And her philosophical views is that the world is a mess.
You mentioned David Chalmers and consciousness a moment ago. And consciousness might not fall under the typical umbrella of philosophy of science because it falls under typically the philosophy of mind. But since we've been talking about metaphysics, there are some metaphysicians who take a very robust view of metaphysics that have interesting views about consciousness. And I'm wondering, just since it's come up, what your views are on consciousness, given that you're a particularly science-minded philosopher. I'm not expecting your theory of consciousness, but maybe how you view it.
Well, you might not know this because it never came up, but my wife is actually an expert on this subject, and she has, I think, written the paper that refutes Chalmers' arguments.
Oh, great.
And have you ever looked at it? And I was in Phil Review some years ago, and she works on it, and has written stuff, and she's writing a book on this stuff now. But at any rate, and her teacher was a person who taught at Rutgers, who was a colleague of mine, named Brian Loewer. He died some years ago, sadly, but I think he had the key idea to show how to defend physicalism against the kind of arguments that Frank Jackson and then David Chalmers, taking Frank Jackson's arguments, developed into his dualist views. And of course, it's interacted with philosophy of science and quantum mechanics in a big way, because for a while in the history of quantum mechanics, people were making claims like consciousness collapses the wave function. In fact, Chalmers just got into a long conversation with Chalmers at dinner a few nights ago about he has actually developed a kind of version, a sort of more sophisticated contemporary version of consciousness collapsing the wave function view. You've heard of GRW probably. It's a spin-off of GRW view. So the two, you can't separate these things. Philosophy is all over philosophy covers everything. That's why one goes into philosophy, because you can't keep your mouth shut. Have you noticed that?
Yeah, but my question is more about how you think consciousness needs to be investigated.
Okay.
Let me just add one other thing.
I buy my wife's view and Brian Loewer's view. I think consciousness is a physical phenomena. I also think that because of the way we encounter our own consciousness, we will never come up with what we think of as a satisfactory explanation of how it is can be the case that neurons doing whatever neurons do can result in something like there's something that's like, to whatever, feel a tickle in your nose or a pain in the butt or what it's like is supposed to be.
While we're on the topic of consciousness, which might be a good case study, to use that phrase again for this, and fundamentalia, the word emergence comes up often in discussions of physics and metaphysics, and it's a heated and charged word. People use it in different ways. What is emergence, and what's an emergent theory? What's perhaps similar in kind an effective theory?
Well, as you said, it's used in different ways. So if one means that certain kinds of things didn't exist at one time, and later on those things came into existence, sure, they emerged. At one time there were no mammals. They emerged. Okay. But sometimes what people mean by that is that there's no explaining how those things emerged in terms of what there was beforehand. If that's what they mean by no explaining, well, again, explaining means different things. If they mean by no explaining, we haven't discussed explanation, what it is. It's another big area in philosophy of science. But if they mean by that you can't come up with what you might think of as a satisfactory thing that you say, now I see, that might be the case. But if what you mean by that is that the world had to have more stuff in it in order to get that, then I don't think that's the case. I don't think there had to be anything in the world other than what there was before there were any mammals for there to be mammals. Mammals emerge very slowly, incidentally. We know that from natural selection, evolution. It takes a long time for everything to happen, so it's not an all or none matter.
I'll leave this up to you, but since you mention explanation, I think that is a good area for us to transition toward. But I wanted to ask if you think it might be better to start by talking about causation, because these two things are interrelated, and I don't know which direction you'd like to start from.
Well, they surely are interrelated. Bertrand Russell was sort of like the Sidney Morgan Besser of his times in philosophy, in that he's great for quotes. His quote about causation, I'm sure you know.
I'll wait for you. I probably can do it verbatim.
I can do it verbatim, right? The concept of causation is like the British monarchy. It should be retired, but it's not, because it's kept around because it's mistakenly thought to do no harm. Now, that's what Russell said. I didn't get it exactly right, but that's what Russell said. I don't think that's right. I think the notion of causation, as Nancy Cartwright came up before, wrote in a paper, is very central to how we think about the world, but I don't think it's fundamental. I don't think that when you get what physics says is fundamental, the notion of causation will be there. And that was one of Russell's points. But you want to keep it around. You want to explain how it emerged, not in the sense of it having to be added, like someone had to come along and say, let's add some causation now, but just explain how whatever the physical stuff it was there, how it getting into certain situations led there to be causal relations among things. And I think giving an account of that is like one of the great tasks of contemporary philosophy. Now, that is not something that scientists will engage in, but it is something that people in philosophy, and to some extent in computer science and decision theory and other things, will enter into, and statisticians. I don't know have you talked to David Papineau?
I have, a couple of times.
So he's writing on this, on his probabilistic approaches to causation, as have Judea Pearl and Clark Gleamore and various other people in computer science and philosophy of science, and Jim Woodward is another interesting person who's written on this in this stuff. There's a whole other approach that comes originally from David Hume, but from David Lewis in particular, which is sort of a counterfactual account of causation. So the throwing of the rock caused the breaking of the window, because if you hadn't have thrown the rock, the window wouldn't have broken. The first account, which is a probabilistic statistical account, it says that when the occurrence of one event raises the probability of another event, or some other kinds of probabilistic relations, and there isn't something like we might call a common causal explanation of why there's a correlation, then there's a causal relation. Now, what I just gave was circular, because I use causation in the account, but the people who do this have a way in which they can get rid of the circularity, they think. These are the two main approaches. One of the projects, if I live long enough, that I want to do is to connect these two projects, these two approaches. So they're connected, because I think if you're going to do counterfactuals and causal counterfactuals right, you've got to make it a probabilistic account of counterfactuals. You got to get rid of David Lewis's approach of counterfactuals. Again, that's for a metaphysics or a logic discussion, not for today, but something else I am interested in. But eventually you're going to want to give an account of counterfactuals in terms of conditional probabilities. And I think when you do that, you're going to have an account of causation in terms of conditional probabilities too, but it's going to be an account of causations between particular events. The throwing of the rock on this occasion, the breaking of the window on this occasion. Whereas the correlational accounts I associated with Papineau and Woodward and Judea-Pearl, is a type causation account. And I think these two need to be fit together in some way. I don't know how to do it now. I don't know anybody who's done it, but maybe that's just because I haven't looked around enough. I just haven't had the time to do it. But that's a really interesting project. You have your own dissertation project right now, right? Or maybe you're going to just be a famous film director. But if you want a dissertation project, this is what I would direct students. I think it's a great area.
You just said many words that I think will be foreign to some of our listeners who aren't familiar with the literature on causation.
I'm sorry.
No problem. So counterfactuals, one of them, conditional probability. I think we should skip the conditional probability for now, but it would be nice to hear what counterfactuals are and how they relate to causation quite broadly.
Okay. So conditionals in English is something that logicians have studied.
Counterfactuals or conditional?
I'm going to talk about conditionals first. Conditionals are statements in English that logicians have studied for a long time. The statements like, if this happens, then that happens. And obviously we're very interested in conditionals because they're the bridges between a this and a that, right? Okay. So, and in ordinary logic that every student who has to take a logic course studies, they study material conditionals. Counterfactual conditionals are not material conditionals. They're a little more complicated. They're, if this had happened, then this would have happened. If they'd counted the votes correctly in the Bohr-Bush election of 2000, Bohr would have been
Gore.
Gore would have been president. I don't know if that's true or not, but somebody might say that.
Bohr-Bush has a nice ring to it, too.
Let me take the example that's used in the literature all the time. If Oswald had not shot Kennedy, Kennedy would have run a second term. I think that's plausibly true, or something like that is true, and the neighborhood is true. We understand that. Now, it's not an ordinary material conditional. It's not what's called truth functional. A truth functional conditional is a conditional such that if you know the truth values of each part, the antecedent and the consequent, you could know the truth value of the whole. Counterfactual is not like that. Counterfactual says something about how the antecedent and the consequent are connected with each other. They are very interesting kinds of statements if you're interested in science, because scientists are interested in these all the time when they're doing experiments. If you were to do this, that would happen. If you had done this, this would have happened. Okay, this is all in the sciences all the time. Causation seems to be closely connected to counterfactuals in the way I said before. The throwing of the brick caused the breaking of the window, because if you hadn't thrown the brick, the window wouldn't have broken. Now, that's not exactly right. It needs to be refined. But that's the basic idea, and the idea that Hume suggested at one point. He has two definitions of causation. This is the second one he gives. But this is the one that David Lewis picked up, and he developed an account of it, and he realized it needed some refinement. He gave refinement, and a big literature developed out of that within what's more properly metaphysics, but it's closely connected to science. It needs to be modified because I think Lewis's account of counterfactuals is no good. He bases his account of counterfactuals on possible world similarity. I think that's a big mistake, but that's off on a side topic, so I'm not going to get into that right now. I think it needs to be done in terms of conditional probabilities, which we can explain in a moment. But that's what counterfactuals are, and that's how causation is connected to counterfactuals. And causation is another thing that I think Russell said too, but other people have picked up, like a guy called Mackey, another philosopher, is that it's the cement of the universe, the glue of the universe. Causation relates one event to another. And I don't really think it's glue or anything like that. That's ridiculous. But I do think it's the concept we use in order to connect events that are connected to explanation. We explain why one thing happened in terms of another by finding the causes of events. At least that's one kind of explanation. It's not the only kind of explanation, but it's the one kind of explanation.
The way that you talk about causation in terms of counterfactuals, it makes it seem very much like just a description, a verbal description of what's going on with causation. In other words, it doesn't sound particularly physical. Or to use the term that you just used, it seems more conceptual. In contrast to what you just attributed to Mackey, where he described causation as a sort of glue, which makes it seem more tangible and real and physical in a certain sense. I'm wondering if you think that this is at all correct, and if it is correct, what some other accounts are of causation that might give it a more physical feel, even if you don't think they're right.
Well, I understand why you said what you said. Now, the idea, which is sort of suggested, but I don't think Mackey believed this, but it's suggested by the Mackey's phrase, is that the world has events in them, the events are loose and separate, and you got to add some glue to connect up what causes what. Now, there are philosophers who believe something like that. It would be a grave oversimplification to say that Tim Maudlin believes that. So don't attribute that I'm saying that to Tim Maudlin. But he believes something in the neighborhood ultimately, but not about causation, but about laws. Okay. But there are other philosophers who definitely believe that. I don't believe that. I don't think that's right. Because of the reasons that Russell said. If you look in fundamental physics, you won't find causation anyplace as one of the fundamental relations in physics. You find spatial-temporal relations, maybe you find entanglement relations in quantum mechanics or something like that, but you won't find causal relations. They sort of emerge in this sort of non-metaphysical sense of emergence that I was using earlier. Okay. So my counterfactual account is supposed to be like that. Now, I do think that there's something physical that makes those counterfactuals come, and that's these conditional probabilities.
Yeah,
I think these conditional probabilities are in physics. And now you're opening up. I wouldn't say this is a can of worms. This is a paradise for me.
Yeah.
This is the main project that I'm into.
You want to show your shirt?
Yeah, this is something called the Mentaculus. Okay.
Yes.
Okay.
Looks great.
Okay, and this is something that's a
Is
project.
that your cat? Is that meant to be your cat? Do you still have a cat? I think his name was Bertrand Russell.
No, it's a little complicated here.
Okay.
So the cat Bertrand Russell was given to me, and I guess when I talked to you last, I did have him as a cat by a student of mine. He named the cat. I would never name a cat anything so gauche as Bertrand Russell. But unfortunately, Bertrand Russell dug up plants. I loved him. He was great. He left on my neck all the time. But when he got off my neck, he'd get off my neck. I could show a picture of my iPad. He'd get off my neck and he'd look around the apartment to dig up plants or to go knock over. We have a lot of things. My wife said he cannot stay in this apartment. So he went back to the farm he lived on. I had a cat before that whom I really loved named Loki. And this is, I think, supposed to be Loki. This shirt was made by a friend of mine with whom I used to go spend time at a place called Paradox Lake. And we had a vacation. Isn't that a good place for philosophers to go?
Yeah.
Do you believe there is such a place?
I like my
You can
desk.
look it up. It's in upstate New York. It's not that far from, what's the closest town? I don't know. Ticonderoga is not some distance. There are other places. But look up Paradox Lake. It's a beautiful, beautiful lake. I can show you pictures of that later if we stop to have them in my iPad. And it's a wonderful place to go. And it's called Paradox because it has two parts. And in the middle part, there's a what do they call it? A little thing that connects to, like not a canal, but a channel. And the water goes in opposite directions in two parts of the channel. And it was thought to be a paradox.
Good.
It wasn't because there were two docks on the lake, as some people. There are many docks on the lake, and it's a great place to go swimming. And so we had a big, gigantic family reunion at this place a year and a half ago, and this friend of mine made this shirt for people there on Paradox Lake, and this is supposed to be a picture of Loki the cat. It doesn't look like Loki the cat. It's supposed to be a picture of.
Yeah. Well, anyway, you were speaking about probability, and you were going to get
Okay,
to
and
your
the Mentaculus.
Yeah.
Is a thing. Again, you're going to talk to David Albert about this in more detail, so I'm not going to get into it.
Yeah, but it'd be nice to hear how it fits in with causation.
Okay, that's my part of it. Okay. So what the Mentaculus is it takes an idea from physics that we came up earlier in our discussion, and that is in during the 19th century. It's related to central things we've talked about, actually, in ways I could emphasize more. Physics studies the special sciences, the macroscopic. It also studies the more fundamental. One of the main special sciences in physics is thermodynamics. Thermodynamics concerns gases, liquids, solids, and how they evolve. But physicists knew they must be connected to the atoms or molecules that make these things up. And the question was, how are these connected? So the physicists who thought about this hard in the 19th centuries with James Maxwell, another one of the greats in physics, and Ludwig Boltzmann, one of the greats. So for me, if you were to have physicists being like mountains, like in the Himalayas or something like that, Mount Everest might be Einstein, and Newton would be right up there, but Boltzmann and Maxwell would be right, sub-peaks, right? Yeah, the other, and Galileo, others. So they were great people. They were interested, Boltzmann in particular, in how to relate thermodynamics to more fundamental physics. And in fundamental physics, thermodynamics studied laws like regularities like this. Ice cubes, when you put them in warm water, melt. Gases, when you let them go, steam, when you let it go, diffuses into the air. Water, when you drop ink, you drop it into water, spreads out in the water. People, when they're born, grow old and die. All these are thermodynamic developments. It was discovered that there was a quantity called entropy. We'll leave it till later for a technical description of what entropy is. But that all of these should in some way fall under the general rubric of if the entropy of some system is not at a maximum, if that system is isolated from everything else, its entropy will increase over time. That's called the second law of thermodynamics. Boltzmann wanted to show how this emerges from more fundamental physics in the sense of emergence that we talked about earlier. But he did realize he had to add something, ultimately, to physics in order to do this. Because he realized he couldn't show that as an exact regularity it emerges, because it doesn't follow as an exact regularity. What follows is that from most of the ways of which atoms or molecules are arranged in an ice cube when you put it in warm water and the way that water molecules are arranged, from most of those ways, the ice cube will melt over time. But there'll be some very, very atypical ways in which it won't melt. So what Boltzmann said is, I have to introduce probability. So he introduced a probability assumption over how the fundamental states of the atoms or molecules might be arranged. For him, in classical physics, fundamental state had to do with where the particles are, or their relative distances from each other, and what their relative velocities are, relative momentums are relative to each other. Okay, well, if you have the fundamental states, well, there are lots and lots of fundamental states which look exactly the same with respect to having an ice cube in warm water. In fact, infinitely many. For most of them, in some sense of most, the ice cube will melt. For atypical ones, they won't. But it turns out if you try to count up with how many atypical and how many typical states there would be, well, and here's somewhat technical things which your listeners might not know, but you certainly know. There are infinitely many of each of these. In fact, there are continually infinitely many of each of them. So you've got to say something more than most. You got to introduce a better notion than most. Boltzmann introduced probability. There are other ways of approaching this. Again, this is not what we're going to talk about now. But by probability, he thought, well, he says a probability distribution such as the probability that the ice cube will melt is going to be very close to 1. And the probability that it won't melt is going to be very close to 0. And if he made this assumption as a probability assumption, and he made this assumption over the whole universe, he could give a very good argument, or kind of argument, that the second law of thermodynamics would very, very likely hold for isolated systems throughout the whole universe, for ice cubes and put in water, for ink drops dropped into water, for gases, seams spread underwater, for people when they're born. It is the case that there are certain arrangements of your molecules compatible with what you look like when you're a baby, such that you will never die. You never will die. There are arrangements like that.
Wow.
But they're very atypical.
I hope I got that one.
You didn't get it.
No.
Probability of it is, minuscule. Actually, you don't really hope it. It wouldn't be not a very happy life if you never died. And again, there are also ones in which instead of, as you mentioned it, there are also ones in which after a little while you end up suffering in horrible pain for a long time. And there are also other ones in which you end up looking like, I don't know, like Donald Trump.
Okay, well, I don't want that one, but maybe I'll take the one where I live 10,000 years. That sounds like a safe bet. I could handle that.
Have a happy life. They're those two. Because, look, if you have continually many things, it's also know what a big number that is.
Quite bigger than infinite, or
it's the second
lowest
order.
card.
It's at least the second order of infinity. Maybe there are many orders of infinity in between. It's a lot. And so there's a lot of room for there are all sorts of things to be.
Since we're talking about aging, I'm wondering, and since we've already talked a little bit, you brought McTaggart up, so we talked a little bit about time. I wonder if you view time travel as a question for the philosophy of science, and whether it may or may not have any bearing on the mentaculus or vice versa.
So Tim Maudlin, as you know, has thought about this, and David Lewis wrote a famous paper in which he tried to make sense of time traveling with his counterfactual account of causation, and he tried to show that there's no real paradoxes. There's a famous paradox, the grandfather paradox, about time travel, where it says that, look, if you could time travel, you can go back and kill your grandfather. Then where would you be? Okay. Well, the answer is, of course, if you went back in time, you just wouldn't kill your grandfather. Okay. Which also, of course, brings up the question between how physics and free will are related. I don't know if you want to talk about that or not, but it's another thing I've written about, and it's an interesting subject. But so with Ince general relativity looks like it allows certain solutions to the Einstein's field equations, which allow for the possibility of there being so-called cause-time-like loops. I believe Tim thinks that while these are allowed by the equations, Tim's own view about what time is should rule them out. I think this should embarrass Tim. But
those are fighting words.
I'm sure look, Tim and I get along well. He can beat me up in any argument that we got into any day of the week.
He could beat me up about what I had for breakfast. He's just good.
That's right. He is the clearest thinker I've ever run into. But he's not right about everything.
That's a very good compliment. Very nice compliment.
It's really true. I mean, it's definitely the case. And the best expositor of stuff I've ever run into.
We've reached another bifurcation where I'll let you decide where to go from here, but we initially got into causation to talk a bit about explanation. I'm not sure we've quite gotten there yet, so we could talk about explanation, or you mentioned earlier your project with David about reductionism.
Maybe I should go back to that because we almost got to that.
Let's do it.
Okay. So we're back to Boltzmann. Boltzmann introduced this probability distribution. He didn't really know what to think what probability is. What is probability? That's a really interesting question. Quote from Bertrand Russell again. This I think I can do verbatim because I love it so much. Russell said, probability is the most important concept in contemporary science, especially since nobody knows what it means.
Another very good one.
Right. Russell was great at this
yes, he was.
thing. And
my favorite, which everyone knows, is it has all the merits of theft over honest toil. Something
that's
like
really
that.
good too. Right. And if you can get away with it, yeah. Try to keep your... It should be philosophy policeman, though, to keep you from getting away with it. So anyway, Tim is one, incidentally, okay. Philosophy policeman, that is. So he didn't know what probability is. I think that one of the main contributions in the history of philosophy in the 20th century is people thinking about this question. There have been a lot of attempts to answer it. There's a very interesting entry in the Stanford Encyclopedia of Philosophy done by Al Hayek, who will also be visiting New York soon, who's another close associate of mine. So I have gotten to know a lot of people who are important. Have you done an interview with him?
I've not.
You should get him.
Yeah, I need to look at your pocketbook.
He's a good interviewer, too, a good person, a good interviewee, very good person, and he knows everything there is about probability. I'm not sure I've drawn him into my camp about this completely. I think I've done it a little bit, but not completely. But, so you might read his article in the Stanford Encyclopedia of Philosophy. It's very good. Basically, there are a lot of different views about what probability is. I think the really great idea was thought up by the person who I think is the towering figure in 20th century philosophy, and that is David Lewis. And David Lewis had a view about laws that's connected with his view about probability. So we're going to connect the two in a little while if you want to talk about laws. We may be running out of time, and when David's going to show up. Lewis had a view about probability. It's part of his best systems account of laws and probability that I think, when you take really seriously, is a view about what objective probability is. Now, another very great idea about probability concerns another Stanford person, or at least he was at Stanford for a while, connected to Nancy Cartwright for a while. They separated. I'm sure you know him as Ian Hacking.
Mm-hmm.
I didn't know him personally. I didn't meet him once, but I didn't know him very much. But I think his book, Emergence of Probability, is also one of the great things written in probability. And in it, he says probability is a Janus-faced concept.
So two faces.
Two faces. Janus was the Roman god with on a coin with two faces. By two faces, it meant one face is what Hacking meant. One face looks at the mind, the other face looks at the world. Probability has an aspect that looks at the mind because it tells you something about what your degree of confidence or degree of belief or degree of ignorance should be in something. But it should be based on what the world is really like. Lewis's account of probability, in the best systems account, is an account that says, here's what the world is like for these to be the right probabilities. Lewis also recognized the Janus face, and he also had a principle that connected the objective probabilities with what your degrees of belief should be like, about what your degree of ignorance should be like. He called this the principle. Again, this is a whole other thing to talk about with somebody who's maybe another occasion. But basically, he thinks that, to put it very roughly, it needs to be refined, that if the objective probability of a certain event is 0.6, other things being equal, your degree of belief in that happening should be 0.6 as well. Now, I think this principle works much better if you're doing conditional objective probabilities and conditional degrees of belief. So if the objective conditional probability of it raining tonight, given such and such facts about the world now, maybe contemporary weather conditions and other situations now, it raining tonight is 0.7, then your degree of belief, given all of that stuff, should also be 0.7. I think that principle is basically correct. But where do those objective probabilities come from? Well, I think they come from Boltzmann's statistical mechanics. Now, why do I think that? Well, Boltzmann's probability distribution was a probability distribution over all the possible fundamental states of the world. And so they give conditional probabilities over everything. Now, there is something we're going to have to conditionalize in order to get the right conditional probabilities. And the person who gave the right name to this thing is David Albert. He called it the past hypothesis. But it's an idea that was floated around. Boltzmann, in some sense, had this idea, but definitely Eddington had it, and Feynman had it, and other people had it. And that is that the world, Penrose has it, that the world had a very, very low entropy state. It's a thing in cosmology, near the beginning of the universe. And when we conditionalize on that, then we'll get the right conditional probabilities when we conditionalize on other stuff later on. Now that we got that, we got conditional probabilities over everything. Now, frankly, I'm sure David knew this. But, you know, I'm an older guy than David. I don't know how he would want to view it. But in some sense, David became a philosopher, in part because he met me. And I was already a philosopher, and he was a physicist, and we got to be friends. But I learned more from him than I did from anybody else. And because he's I wouldn't say he's the clearest thinker. I wouldn't say David is the clearest thinker. David is not as, he's very clear, but he's not in the same way that Tim is. But David is the most creative thinker I've known. And so I learned a lot, and he was very willing to teach me. And I think a lot of what came from David, he came in interacting by me saying, yeah, do you really think that? Or, well, look, if that's so, then what about this? So I don't know how much he would want to bring me into this. I shouldn't bring myself into his views. He should let him do that. But I certainly learned a lot from him. So I do know that when we were talking about it, when he was writing his book, Time and Chance, we were talking about it a lot. And I came to see, and like I said, he probably realized this all along, that look, if you had this view about statistical mechanics, that the view about statistical mechanics is that when the world began, it began in this low entropy state, and there was a probability distribution over all the possible fundamental states of the world that the world could be in, you would end up with probabilities or conditional probabilities over everything, including the conditional probability over Harris winning the current election, given such and such facts about the universe now. Okay, and if you think about it for a second, well, of course, because if you knew the whole fundamental physical state of the world now, you would know whether Harris would win the election or not, right? As Laplace pointed out to Napoleon, they say, a long time ago, okay. But of course, we're never going to know the fundamentals. It's not a possibility. It's not even a physical possibility. So we call this the mentaculus. That's what this shirt is about. And this is a project that we've been working in. And now if you Google mentaculus, the word, of course, as you know, comes from the film by Ethan and Jonathan Cohn called A Serious Man, where there's a minor character scribbling in a book, and someone says, what is that book? And he says, it's the mentaculus. And someone says, well, what's that? And he says, it's a probability map of the world. And that's what this is. It's a probability map of the world. So we just took this from Ethan Cohn. Now, I quickly add that the character in the film is clearly out of his mind and is meant to be depicted like that. And we thought that when I tell other people that I think there's objective probabilities over everything, the first thing they're going to look at me, Lewis said people looked at him with an incredulous stare when I told them about all the possible worlds. I do think they'll look at me with an incredulous stare when I tell them there are probabilities over everything. But I do think a good argument can be made for this. Next thing I want to say about it is that David and I got to know Ethan Cohn because of this, because I had Ethan Cohn's emails. I emailed him, and he said he wanted to talk to us. So we talked. We used to meet him regularly at a cafe not far from here and talk about physics, and we emailed with him until recently. I used to get 2 or 3 emails a day from him about stuff we'd argue about. I don't want to get into that, okay? But I do think the mentaculus is a serious philosophical project. Whether it'll survive philosophical scrutiny or not, that's a question. It's come under some criticism by some people, and some replies to it, and there is issues that's closely related to reductionism, because I do think it can be used to support my kind of reductionism, the kind of reductionism in which there's emergence without adding anything more to the universe other than this probability distribution and the past hypothesis. And those are really scientific things that you're adding to the universe.
I tend to lose track of time during these conversations, so I'm not sure if it was 15 minutes ago or half an hour ago that you mentioned free will. But I would be very curious to hear whether you think free will is a problem for philosophy of science or for science in general, and how you just think about free will in general.
Well, many scientists have thought about free will. I know that. I just talked to one who came to a lecture I gave about free will, and so they're interested in it. They have an inkling feeling that maybe what they learn about in science somehow has some incompatibility with there being free will. And there have been metaphysicians, a famous one who's wrote a couple of books about this, named Peter van Inwagen. I don't know if you know his work or not, okay? Was given an argument, a famous argument. I'm not sure he's the first person who thought up this argument, but he definitely gave it a clear formulation, called the consequence argument, which is supposed to show that free will and fundamental physics are incompatible with each other. And the idea is that if there are laws over everything, whether they're deterministic or whether they're probabilistic, there's no room for free will.
Why is that? How does the consequent argument?
Okay, I'll do it for determinism. Things are a little fancier if the fundamental laws are indeterministic. But there's good reason to think that the fundamental laws, even of quantum mechanics, are deterministic. Whatever you may have heard about quantum mechanics. Okay, but there's another.
Well, Tim's somebody who thinks that they're deterministic.
Tim thinks they're deterministic. Let him.
People can listen to our episodes on Bohmian mechanics.
Yeah, okay. So I'm with Tim about that. Okay, so the basic idea is this. It's really simple, very straightforward, easy to explain. Look, if you have free will, it's got to be the case that your actions will make a difference to what happens. So what does that mean? Well, we're back to counterfactuals now, which means that if you were to decide to do this, that would happen. If you were to decide to do something else would happen. If you have free will, that's got to be the case. But now Peter van Inwagen comes along and says, but look, you're not free about what things that happened in the distant past, are you? If you were to decide to do this, it wouldn't make a difference to stuff in the distant past, would it? Most people would respond and say, well, of course not. I mean, I can't do anything about this.
Makes sense to me.
Can't do
naively.
Wait a few minutes, okay?
Okay.
Can't do anything about, you can't no crying over spilled milk. And you can't do anything about the laws, right? The laws are the laws. You can't decide to break the laws. If you jump off, if someone pushes you off the building, you can't say, I'd like to suspend the law of gravity now so I fall gently to the ground. It's not going to work, right? You can't do that. But the laws in the past, if determinism is right, entails what will happen in the future. So it looks like it validly follows, and I do believe it does, as Van Inwagen said, that you can't do anything about the future. Therefore, you have no free will. That's the argument. I think the argument is a valid argument. Now, logicians or philosophers say, well, a valid argument is only good if it's sound as well as valid. The premises both have to be true. So let's look more carefully at the premises. One says you can't do anything about the laws. The other one says you can't do anything about the past. Now, David Lewis wrote a famous paper about this in which he said, well, when you look at the right way to evaluate counterfactuals, it'll turn out to be the case that if you had decided to do something different, then in fact, you would have violated a law. But in the past, you would have violated a law. So you're not going to be able to suspend the law of gravity in the future. I think Lewis's way of doing counterfactuals is wrong. So I think the right way to evaluate counterfactuals is that when you evaluate counterfactuals, nothing you do would ever violate laws. Okay, we're going to get into more details about counterfactuals if just people who listen to this podcast really could understand it. I do think that if you were to have decided to do something, if you were to decide something differently from what you actually decide, then the past would have been different way back to the Big Bang. And in fact, statistical mechanics shows how that could be the case. But be careful about it, because you won't be able to affect anything macroscopic in a way that you care about. What was the case is that had you decided something different, then the microscopic history of the world would have been different microscopically, while the macroscopic history of the world would have been exactly the same. And that's because of something that everyone who studies statistical mechanics knows about. I'll do it in a vivid way. It's called something called the butterfly effect. And that's that very small differences in the microscopic state could make for a very big difference in the macroscopic state later on. The butterfly effect means that a very small difference in the macroscopic thing that determines whether a butterfly flaps its wings or not in Africa might make for a difference whether that's a storm off the coast of the United States, sometime later. And that's right. Okay, so I illustrate that with a. I'm not wearing the right T-shirt to illustrate that. My other T-shirt.
You've got a lot of T-shirts. I like them.
And stuff, right? But basically, if you were to give a history of the universe, if you write a history of the universe microscopically and you move into determinism, it would just be a straight line. If this is the fundamental microscopic state the world started in, that was the way it would go on forever. But if you did it macroscopically, it would be branching. So at the macroscopic level, the world is full of chanciness. And the chances come from the statistical mechanics and this Boltzmannian account that I told about earlier. That's where the mentaculus comes from. And the idea that this is so, like I said, I think David had this idea when he was writing the book, but the idea that this has such consequences for philosophy that I really just stumbled into because I knew David, is fantastic. I think it's incredibly powerful idea for philosophy. It has consequences for how to think about counterfactuals, causation, knowledge, epistemology all over the place, and so on. So I think it's a total great field for philosophy. So the mentaculus, and I'm writing a book now. The book is called The Mentaculus Vision. And it's basically about how you take this idea and its consequences are for philosophy all over the place. Like people when they do in philosophy, they write a book and other people come along and they tell you what's wrong with what you're doing. I'm sure that'll be the case here. And maybe it's wrong from the very beginning. So for example, Tim's way of approaching statistical mechanics doesn't use probability, it uses typicality. And he might object from the very beginning. But his way is not the typical way of approaching quantum mechanics. If we were approaching statistical mechanics, if I could say that, to use the word typicality back on Tim. Most people who do statistical mechanics use probability, not typicality. But Tim belongs to a tribe which uses typicality.
That was an excellent story. Now, I would love to talk about laws a bit more. They came up at the beginning of our conversation, and they've come up a lot now, so it might be a good time to get a bit clearer about them. I think a good question to start with is just the landscape of views on what laws are, and I'll give you two options about views. So one takes laws to be maybe more conceptual. They're descriptions of generalities of things. Another takes laws to be something more robustly metaphysical, something baked into the fabric of the universe, something that might be commanded by God. I'm wondering if there are words or terms of art to describe these views, what these views are, if you could elaborate on them more, and if I'm right, if these are two good poles in the landscape.
You're absolutely right. It's a good way of describing it, and it connects up with two things we talked about earlier, namely chances and causation. So let me say a little bit more about views here, and a little bit about the history of the concept of law. Is that okay? We have time for that?
Absolutely.
In the history of the concept of laws, like I said much earlier, that the contemporary concept really didn't come up until the 17th century with Galileo, Descartes, Newton, and so on. Some other people, Gassendi, Boyle. And basically, it was very theologically connected. Laws were thought of as the principles that described how God moved matter around. That's definitely how Descartes thought about laws. So he did connect it with theology. God gradually fell out of it. And I think Newton thought about it like that too, frankly. That's a more subtle question. But God fell out of it because you didn't want God into science so much, not to everybody. And in fact, another quote I'll tell you about, that two people who, I guess I use this quote, it's a quote from me. That's a good personal quote.
Yeah, the best.
Is that, but both Nancy Cartwright and a philosopher called John Foster held it. And that is, if there were no God, there'd be no laws. John Foster used it, and he used it as an argument for the existence of God, because he thought there were laws. Nancy Cartwright used it, and he used it as an argument for the existence of for the non-existence of laws of this sort. I think it's wrong. I think you can have laws without God, but not of the robust sort that you were talking about before. And the person who had a view about what laws are of a non-robust sort that I think works out pretty well and it's closely connected to his view about probability or chance was David Lewis. So here was David Lewis's idea, or maybe I tell you about the other idea first a little bit. So in philosophy, there wasn't much written about what laws are. That's a philosophical question in the history of philosophy. Kant had some Kantian view, but while there are people at Stanford, I think, who understand what Kant has to say, I've never really had a conversation with him about this. I would like to at some point in my life. I don't know if I've ever really talked to Michael Friedman, but I'm sure he knows a lot. Surely knows a lot more about Kant than I'll ever know about Kant. So Kant wrote about this, but he had his sort of Kantian view. But in the 19th century, people just didn't write about this much. Peirce says a little bit about it. And then the positivists were very down on metaphysics. So then in the late 1970s, 1980s, some philosophers were more metaphysicians when the logical positivists were thought to have been killed off by, I don't know, who killed them off? Popper and Quine in different ways or something like that. They were free to have metaphysical views. So Armstrong had the view that he had a robust view. Laws had to be added to the universe over and above the ordinary facts in the universe. You have to add connections between universals for there to be laws. He called them connections of contingent necessitation. Swallow that if you can.
Laws of contingent necessitation.
That was Armstrong's view. You can't ask him about it because he died some years ago. Tim has the view that laws are just what they are. They're just extra things that you add to the universe, and they make things happen in the universe. I think this is, I don't know what you say. Should I say bananas?
Bananas works.
I think you just can't make sense of how this is supposed to be. But Tim disagrees with me about this, and Tim's a very smart man. So here's David Lewis's views. All there are the ordinary facts. He's more what you said as a conceptual side, although I'm not sure I'd go along with that quite way of doing it. But it's a non-robust in the sense you meant robust. I think that's how it should be. You should be robust about the things that really exist. You shouldn't be robust about the things that you don't think exist. So what are laws? Well, his view about what laws are is that, look, there are the ordinary facts. There's the whole history of ordinary facts. And what we're interested in laws are finding out the best systematization, the best ways of organizing, systematizing, unifying all of those fundamental facts. That's what the laws are, entailments of the best systematization of all of them. That's what laws are. Now, I'm just so close to it, I'll add this. What chances are is we introduce probability as a way to help us systematize the ordinary facts. You can see how that might work. Because if, for example, the ordinary facts consisted of the outcomes of coin tosses. Now, we don't think those are fundamental facts. But if they're HTT, we might see, gee, if we were to describe that in a fundamental way, that would be very, very complicated. But probability might enable us to describe that in a simple way and give us a lot of information about it. That's what Lewis's idea. So Lewis's idea is the best systematization optimizes simplicity, informativeness, and other criteria that science is after. And laws are what's entailed by that best systematization of the world. Now, I think that's pretty robust.
This raises a very interesting question. We've already talked about Leonard Susskind, so let me just bring him in here for a moment. You're obviously aware of the string theoretic multiverse, where there are upwards of 10 to the 500 pocket universes. And in each of these, ostensibly, there lives a different physics. This is how the string theorist like Leonard Susskind accounts for the fine-tuning problem. And the reason that there are different physics in these different pocket universes has to do with the fact that each of these universes corresponds to one of the, say, 10 to the 500 ground states of the string or different fluxes, things like this. So there are different physics, laws of physics, ostensibly in these different pocket universes. Does that mean for you that the laws of nature can vary across time and place?
Look, first of all, in Suskind's view, is he thinks that there are laws that hold in all these universes, namely the laws of string theory. So what he's doing is modifying or changing some of the parameters in these laws to get these different universes. The same is true in Newton's universes too. Change the positions and momenta of the particles in the universe, and you get different universes. Now, Newton had no reason to say they really exist in the same sense. I'm not sure Susskind does either, for that matter. Cosmologists, everybody has their favorite multiverse. Susskind gets them out of string theory. Alan Guth gets them out of inflationary theory, which maybe he can connect to string theory or maybe not in some way. And David Lewis gets him out of his metaphysical multiverse. And there are some philosophers, Alistair Wilson, have you talked to him? He tries to connect up. He's a British philosopher, tries to connect up the Lewis with one of these. I'm not sure which one he does it with, actually. I'm not a fan of any of that stuff. But anyhow, okay. But I think Susskind has gone off the deep end here a little bit. Because first of all, his many verses uses, you could do the same thing with Newton. Now, why does he think they really exist? Does he say that? Does he answer that question?
Because he doesn't think that there's any better explanation for solving the fine-tuning problem.
Okay.
But I think also it has to do with the cosmological constant. I think that's a very big part of it.
Well, that's the fine-tuning problem.
I know, but it's a bigger part of it to him than the other the constants of the standard model.
Why does he think this is better than God?
Sorry?
Why do you think it's a better explanation than God?
Because he thinks that God is metaphysics, and he doesn't go in for supernatural explanations.
I think what he's doing is metaphysics.
Okay.
Or something.
In the pejorative sense.
What he's doing is bad metaphysics or bad physics.
Okay.
Okay, I mean, I'm not sure I'd be willing to say that to Leonard Susskind if he's in the room, because he's a real physicist. But look, I understand what he's saying, and I think the fine-tuning problem is a very interesting problem. But I think the idea that you're doing this as an explanation is based on a mistaken view about explanation, in fact. And in fact, fine-tuning will be the last chapter of my Mentaculus book.
Oh, that's terrific.
Okay.
I find it a very fascinating problem.
I do think it's a fascinating and interesting problem. And have you talked to Dean Zimmerman at all? No. He's a colleague of mine also at Rutgers. He's more philosophy of religion, but he's also a metaphysician who also, I think, knows he should be paying attention to physics stuff, and he does a little bit about it. And he's a great human being, is what I'd say about him. He's currently the chair, so he may not have no time to talk to you about anything, but he has a whole big project from Templeton on the fine-tuning problem that both David and I have talked in, and I'm interested in fine-tuning problem, and I think there are some philosophers who've gone in totally the wrong direction about the fine-tuning problem also. John Hawthorne is one. Did you talk to him or not?
No.
Okay, because they're not philosophers of science. But I do think they're making a certain elementary philosophy of science mistake, as I think Leonard Susskind is making. So maybe you should talk to philosophers of science a little bit more frequently in order to think that he should go in that direction to come up with an explanation of the cosmological constant.
Right, but as you mentioned, he's not interested in talking to philosophers
but
at all.
He talked to you. He said, I don't know, where did he get that from? Did he know Patsoupi's?
Well, my guess is that it comes from, and some people don't think that this distinction holds water anymore, but it comes from continental philosophy and people like Latour, somebody I have.
Has he read Latour?
I have no idea.
Nobody at Stanford probably has ever read Latour. Nobody in philosophy that I know has ever read Latour. I know a little bit about Latour because I live in France, but he's not in analytic. A lot of people in analytic philosophy. There's some people who do philosophy of science now who want to bring in continental philosophy a little bit, but I don't do that because I don't know that much about it. And Habermas, I think, is a Habermas.
Yeah. Well, you, I take it, think that there is a distinction between continental and analytic philosophy.
There is, in a sense, yeah. But if you've looked at continental philosophy now, it's being taken over by analytic philosophy, or what I think of as analytic philosophy of science. So I'm giving a talk at LMU, Munich, in December, where is a great department. And in fact, somebody from California, a friend of mine also, I'm sorry to say that I'm bringing up people I know, because I only bring up people I know. Alyssa Ney, have you talked to her? So she just took a position. She was at Davis, but she just took a position as the chair of metaphysics, but she's a philosopher of quantum mechanics. She's edited a book on the wave function realism with David, actually. Maybe she was the only editor, I'm not sure.
Well, Barry, we have run the gamut on the introduction to the philosophy of science. Of course, we couldn't cover everything in this period, but it's been absolutely excellent. Thank you so much for taking the time.
Thanks. I'm sorry we didn't do a standard course. I put out a syllabus of a standard philosophy of science course. There's a lot of standard things we didn't talk about because I don't teach it in quite a standard way. And we did talk about a lot of things I'm interested in. I had a good time. So
I'm looking forward to the next round.
Okay, fun.